Picture upgrading your car engine, spending everything you have on the best parts money can buy, and then watching the new engine arrive 3 years too late to actually save the business it was supposed to rescue. That is roughly what it feels like to trace the King Tiger story from design table to battlefield. And once you see the pattern, you cannot unsee it in almost every other failed technological gamble history has ever produced. Now scale that feeling up to the size of a war. In 1944, Germany finally rolled out what should have been the most terrifying tank of the entire Second World War, a heavier, better armored, more powerfully armed successor to the already feared Tiger, built specifically to correct every weakness engineers had learned about the original design on real battlefields. On paper, it was nearly untouchable. In practice, it arrived so late, so underpowered relative to its own weight, and in such small numbers that it barely changed the outcome of a single battle it fought in. This is the story of the King Tiger, the upgrade that was supposed to save Germany's war on the Eastern and Western fronts alike, and why building the most dangerous tank in the world means absolutely nothing if you cannot get it to the battlefield in time, in numbers, and with a crew that knows how to keep it actually running. If you're the kind of person who gets pulled in by stories where the engineering was genuinely brilliant, but the timing destroyed everything anyway, subscribe right now so you don't miss the next one, because this pattern shows up again and again once you start looking for it across military history. Tell me in the comments if you'd ever heard of the King Tiger before today, because I want to know how many of you only know the original Tiger and had no idea Germany tried and failed to build something even bigger. A like helps this reach more people who'd get exactly as much out of this as you're about to. Now let's get into how Germany's most feared upgrade turned into one of its most expensive mistakes. To understand why this upgrade mattered so much to German commanders, you first have to understand exactly what it was replacing and why that original tank had already earned such a fearsome reputation across the Eastern Front. The original Tiger entered production in August 1942, a nearly 57-ton vehicle armed with an extraordinarily powerful 88mm gun, wrapped in armor thick enough that few Allied or Soviet weapons of the period could reliably penetrate it from the front at any reasonable combat range. It emerged directly out of a shock German commanders experienced in 1941, when their forces invading the Soviet Union encountered the T-34 and KV-1, tanks whose sloped armor and heavier guns outclassed anything Germany had fielded up to that point. German General Heinz Guderian, one of the architects of the Blitzkrieg doctrine that had conquered so much of Europe with such shocking speed, wrote candidly afterward about the genuine alarm the T-34's appearance caused within German ranks. The Tiger was Germany's answer, rushed into production, genuinely formidable in individual combat, and genuinely nightmarish for every enemy crew unlucky enough to face one directly. But it was also mechanically fragile, brutally expensive, and painfully slow to build, problems that never went away and that German engineers, even as they raced to design something even more powerful, never actually solved. That fragility is exactly where this story really begins, because German commanders never treated the Tiger I as a finished product. They saw it, almost from the moment it entered combat, as a stopgap, something that worked well enough to hold the line while a genuinely superior successor was designed from the ground up. That successor was the Tiger II, more commonly remembered today by its nickname, the King Tiger. And the ambition behind it was staggering, a design brief that essentially asked engineers to fix every single weakness of the original Tiger simultaneously, without ever fully reckoning with how much additional weight and complexity each individual fix would add to the finished vehicle. Nearly 70 tons of steel, armor sloped and thickened even beyond the original Tiger's already imposing protection, and an even more powerful version of the 88mm gun, one capable of punching through the frontal armor of virtually any Allied or Soviet tank at ranges where those same tanks could barely see the King Tiger clearly enough to return fire. Here's the twist most people miss entirely when they hear about the King Tiger's specifications for the first time. On paper, it should have been unstoppable. In the design documents, on the drawing boards, in the theoretical performance tables German engineers produced, this tank looked like the single most dominant weapons platform of the entire war, capable of destroying any Allied or Soviet tank in existence while remaining nearly immune to return fire from the front. And that gap, between what the numbers promised and what actually happened once the tank reached a real battlefield, is where this entire story lives, and where nearly every account of the King Tiger you have ever encountered before today probably stopped short of actually explaining. The design competition behind the King Tiger followed almost exactly the same strange, wasteful pattern that had already played out once before with the original Tiger. Two separate design teams, one from the automotive firm Henschel, the other led by the famously stubborn engineer Ferdinand Porsche, competed to deliver Germany's next heavy tank. Porsche, so confident his design would win the contract that he had already begun preparing components for production before any official decision had even been made, lost the competition a second time, just as he had with the original Tiger. That overconfidence was not a small miscalculation. Porsche had committed real factory capacity and real materials, resources Germany could not afford to waste twice in a row on a losing bid, to a design the military ultimately rejected in favor of Henschel's more practical hull. Henschel's design was selected instead. But because Porsche had already built a batch of turrets for his version before losing, German industry, desperate not to waste materials it could no longer easily replace, mounted roughly 50 of those Porsche-designed turrets onto the very first production King Tigers anyway, creating two visibly different turret types on what was supposed to be a single standardized tank. A genuinely strange compromise born entirely out of wartime waste avoidance rather than good engineering sense. The King Tiger finally entered combat in the summer of 1944, first appearing in meaningful numbers during the fighting in Normandy following the Allied D-Day landings, and later that same year during the Ardennes Offensive, the massive German counterattack through the Belgian forests that Americans would come to know as the Battle of the Bulge. And it was here, in actual combat, that the enormous gap between the tank's theoretical power and its practical usefulness became impossible to ignore. Start with the engine, because this is where the entire upgrade quietly fell apart before a single shot was ever fired. German engineers had made the King Tiger dramatically heavier than its predecessor, adding armor, adding weight to the hull, adding an even larger gun and the ammunition to feed it. But they never paired that additional weight with a correspondingly more powerful engine. The King Tiger used essentially the same Maybach HL230 engine that had already been straining to move the original, considerably lighter Tiger I, asking that same engine to now haul nearly 70 tons of steel across muddy fields and shattered roads was, in hindsight, an almost predictable engineering failure waiting to happen. The tank was chronically underpowered relative to its own mass, meaning it struggled with acceleration, struggled climbing anything resembling a steep grade, and burned through fuel at a rate that would have strained even a well-supplied army, which Germany, by late 1944, very much was not. Crews trained on the original Tiger, I often described the King Tiger as feeling sluggish and unresponsive by comparison. A machine that looked more powerful in every specification sheet, but actually handled worse in the field. Exactly the kind of gap between paper performance and lived reality that would define this tank's entire operational history. Even getting the King Tiger to the battlefield in the first place created its own genuine logistical headache. The tank was so wide that it could not travel by rail using its standard combat tracks, forcing crews to swap them out for a narrower set of transport tracks before loading the vehicle onto a train, then swap them back once it reached the front, a time-consuming, labor-intensive process that slowed deployment and gave maintenance crews yet another point of failure to worry about before the tank had even fired a shot in anger. Every single one of these small, individually manageable inconveniences compounded on top of each other, turning what should have been a straightforward deployment process into a sequence of delays that, added together across an entire production run, meant King Tiger units routinely reached the front weeks later than originally planned, arriving into tactical situations that had often already shifted by the time they finally showed up. Fuel scarcity alone crippled the King Tiger's effectiveness in ways no amount of armor thickness could compensate for. By the time these tanks reached the front in real numbers, German fuel reserves had collapsed under the combined weight of Allied bombing campaigns targeting oil production and refining facilities, particularly the sustained strategic bombing directed at synthetic fuel plants scattered across Germany, alongside the sheer, grinding attrition of years of continuous warfare that had steadily worn down every reserve the country had once stockpiled. Crews reported abandoning perfectly functional King Tigers simply because they had run completely out of fuel, tanks that Allied forces later captured intact, undamaged by enemy fire, disabled entirely by an empty tank they had no way to refill. Supply officers responsible for keeping frontline units fueled increasingly found themselves choosing which units received the scarce fuel that did arrive, meaning entire King Tiger companies could sit motionless for days while commanders elsewhere on the front made impossible decisions about where Germany's dwindling reserves would actually go. Think about that for a second. The single most heavily armored tank Germany ever fielded, a machine theoretically capable of shrugging off nearly anything an enemy could throw at it, was regularly defeated not by combat at all, but by simply running dry on the side of a road. Mechanical reliability compounded the fuel problem into something close to a systemic collapse. The transmission, designed to handle the original Tiger's weight, now had to move a vehicle nearly 40% heavier, and it broke down constantly under that strain. Track failures were common. Suspension components wore out at rates that overwhelmed Germany's already stretched maintenance and spare part supply chains that were themselves being bombed, rerouted, and disrupted by an Allied air campaign that had, by 1944, achieved something close to total air superiority over the battlefield. Repair crews who might once have fixed a broken transmission within a day or two now faced weeks-long waits for replacement parts manufactured in factories that were themselves being bombed or forced to relocate. A cascading breakdown in which every single link of the supply chain feeding the front had its own separate crisis unfolding simultaneously. A King Tiger broken down on an open road was not just useless. It was a sitting target, visible from the air, unable to move, waiting either for repair crews that frequently never arrived in time or for an Allied fighter bomber to find it first. And here's a detail that genuinely surprises most people once they hear it. Historians studying the King Tiger's overall combat record have found that a significant share of the tanks Germany actually lost during the war were never destroyed by enemy tank fire or anti-tank weapons at all. They were abandoned, broken down, out of fuel, stranded, and deliberately destroyed by their own crews specifically to prevent them from falling into enemy hands intact, a fate that had nothing to do with the tank's armor or firepower and everything to do with the fact that Germany, by the time this weapon finally reached the front in real quantity, could no longer reliably fuel it, repair it, or protect it from the sky. Crews who had trained for months to master a genuinely powerful weapon system found themselves instead spending most of their operational time managing breakdowns, coordinating scarce fuel deliveries, and making desperate decisions about whether to abandon a vehicle they knew, deep down, they would never be able to recover once it stopped moving. Production numbers make the entire picture even more stark. Across the entire war, Germany built roughly 1,350 Tiger I tanks. The King Tiger, its intended successor, its supposed answer to every weakness the original design had revealed, managed only around 492, a fraction of an already tiny production run, manufactured almost entirely during a period when Allied bombing was actively targeting the very factories responsible for building them. Compare that against the tens of thousands of T-34s the Soviet Union was producing during this same period, or the equally enormous production numbers coming out of American factories, and the King Tiger's fundamental problem stops being a mystery. It was not beaten because it was a bad tank in isolation. Individual King Tigers, in the rare engagements where fuel, mechanical reliability, and enemy air power all happened to align in Germany's favor, performed with genuinely devastating effectiveness, destroying Allied and Soviet armor at ranges those tanks could barely return fire across. But 492 tanks, arriving in the war's final year, chronically undersupplied and mechanically compromised, were never going to change a strategic outcome that had already been decided by industrial capacity, not individual tank quality. That is really the entire lesson buried inside this story, and it deserves to be stated plainly rather than left implied. Germany spent enormous engineering talent, scarce raw materials, and precious manufacturing capacity chasing a tank that was, by nearly every individual technical measure, superior to anything the Allies or Soviets could field. And it barely mattered. The upgrade arrived too late to influence the war's outcome, in numbers too small to matter strategically, tied to an industrial and fuel supply system too broken to actually support it once it reached the field. A weapon's raw specifications on paper have never been the same thing as its actual battlefield value, and the King Tiger stands as one of history's clearest, most expensive demonstrations of exactly that gap. Consider what Germany could have accomplished if the resources poured into designing, tooling, and slowly hand-building 492 of these mechanically fragile giants had instead gone toward producing several thousand more of the already proven, if imperfect, Tiger I, or towards simpler, more reliable medium tanks that Germany's train factories could actually churn out fast enough to matter? That question haunted German engineers themselves in post-war interviews, several of whom acknowledged, once the pressure of wartime secrecy and propaganda had lifted, that raw technical superiority had become something close to an obsession within German tank design by the war's final years, chasing bigger guns and thicker armor at the direct expense of the reliability, simplicity, and sheer manufacturability that had actually decided the outcome of the broader industrial war. The Ardennes Offensive in December 1944 illustrates this failure with almost painful clarity. German commanders committed King Tigers to this desperate, last-gasp counterattack, specifically hoping their raw firepower and armor could punch a decisive hole through thinly defended American lines before Allied reinforcements could respond. The entire operation depended on speed, on German forces punching through quickly enough to capture Allied fuel depots before their own reserves ran dry. A plan that reveals just how aware German planners already were of the exact vulnerability that would go on to doom so many of their heaviest tanks. Some individual engagements did go Germany's way. King Tiger crews using their long-range gun advantage to destroy American armor from distances American tanks simply could not match, picking off Sherman tanks and tank destroyers before those crews ever had a realistic chance to fire back. But the offensive as a whole collapsed within weeks, strangled by exactly the same logistical failures crippling every other part of the German war machine by this point. Fuel convoys that never arrived, roads clogged with broken-down vehicles competing for the same narrow mountain passes, and Allied air power that, once weather cleared enough to allow it, methodically hunted down stranded German armor from above. Individual King Tigers won individual duels. The war, and the offensive built around trying to save it, was already lost before most of these tanks had fired a single shot. Soviet forces on the Eastern Front encountered the King Tiger in similarly limited numbers during the final year of the war, and Soviet accounts from these encounters echo almost exactly the same pattern documented in the West. Individual tanks performing with real lethality in isolated engagements, while the broader German war effort surrounding those tanks continued collapsing under the weight of fuel shortages, overstretched supply lines, and an industrial base being steadily ground down by continuous Allied and Soviet bombing. By early 1945, King Tiger units on both fronts were reporting operational readiness rates far below what German planners had originally hoped for, with a substantial share of the tanks assigned to any given unit sitting immobilized at any one time, awaiting parts, fuel, or repairs that increasingly never came before the war itself ended. There is a version of history where the King Tiger arrives in 1942 instead of 1944, backed by Germany's still intact industrial base and fuel reserves from earlier in the war, deployed in the kind of numbers that might have genuinely reshaped individual campaigns on the Eastern Front. That version of history never happened, and the reason it never happened says something worth sitting with, something that reaches well beyond the specifics of any single tank design. Superior engineering, pursued in isolation from the industrial and logistical systems required to actually sustain it, does not win wars. It produces expensive, individually impressive machines that end up abandoned on roadsides, destroyed by their own crews, or picked apart by enemy aircraft while sitting motionless with an empty fuel tank. The gap between what a weapon can theoretically do and what it can actually deliver under real conditions, with real supply chains, real crews, and a real enemy actively working to disrupt every single link in that chain, is where wars are actually decided, and Germany learned that lesson at a cost measured not just in tanks, but in the entire strategic outcome those tanks were built to change. That same gap shows up constantly outside of warfare too, in almost any organization that pours everything into building the most technically impressive version of something without asking whether the surrounding systems can actually support it once it exists. A brilliant product nobody can manufacture at scale. A powerful engine nobody can fuel reliably. A perfect design arriving 3 years after the moment it could have actually mattered. The King Tiger was not a failure of engineering. Individually, it was one of the most formidable tanks ever built, capable, on a good day, with a full tank of fuel and a functioning transmission, of dominating almost anything it encountered on a battlefield. It was a failure of timing, of industrial capacity, and of every unglamorous system standing between a brilliant design and a battlefield that was never going to wait patiently for Germany to catch up. Somewhere today, in a boardroom or an engineering department far removed from any battlefield. Someone is likely making the exact same mistake, chasing the most impressive version of a product without asking whether the surrounding factory, the supply chain, or the timeline can actually deliver it before the moment that mattered is already past. The King Tiger remains one of history's most expensive reminders that being right about the engineering is never the same thing as being ready in time.